Hello everyone, welcome back. So, what is our today's topic? Today's topic is relative speed. It's a bit related to a clock, but before going to any other topic related to clock, let us understand what is this relative speed. Now, as you can see in the picture, there are some objects which are moving down, and you can see all the objects are moving in the different speed. We all know the speed of the object depends on its weight, correct? But now, how can we relate it to that clock? So, as you can see in the picture, when two objects move in the same direction, like here we can see two objects or two stickmans are moving in the same direction. Okay, and when they are touching each other, so there is some action being there. Now, both the objects are moving in a same direction, but maybe with a different speed or velocity or whatever you can say. Our main object is two objects are moving in the same direction. Now, when two objects are moving in the same direction, have to calculate their speed. That is our today's task. Similarly, what we can say when two objects are moving in the different direction, then have to calculate their speed. So, the term says when two objects move in the same direction, to find the relative speed, we should subtract their speed. That is speed of the first object minus speed of the second object. And when two objects move in the different direction, that for example, one is going in the right and other is going in the left, at that time we have to add their speed to get the relative speed. Now, as we are on the topic clock, so what is the speed or what is the use of relative speed here? You can see in this clock, two hands are there, hour hand and the minute hand. Both are moving in the same direction. Now, when we have to calculate certain things, we need to check the speed. Which speed we have to take? The hour hand or the minute hand? So, the answer is we have to take the relative speed. How can we calculate the relative speed? So, in this picture, you can see in the clock, in normal any clock, the hour and minute hand are both in the same direction. So, just now we have learned when two objects or both the objects whose speed we have to calculate are in the same direction, we have to subtract their speed. Now, when we talk about the hour hand, so we all know the hour hand and the minute hand walk or move in the same direction but with totally different speed. In 1 hour, the hour hand is traveling only for 5 divisions, whereas the minute hand is traveling for your entire 60 minutes, correct? So, how can we find that? So, we know the formula, speed equals to distance upon time. The speed of the hour hand is only 5 divisions in 60 minutes. Just now we have seen. If we are talking about the time between 2 and 3 p.m., so when it is 2 o'clock, the hour hand is 2. And when it would be 3 o'clock, the hour hand would be at 3. So, between 2 and 3, the distance which is being covered is only 5 divisions and in 60 minutes. Similarly, at the same time, when we talk about 2 o'clock, the minute hand is at 12. And when we talk about 3 o'clock, the minute hand is again 12. But it has traveled all the 60 divisions. So that is 60 divisions in 60 minutes. So the relative speed is 1 minus 1 by 12. If you will use your basic math, it would be simple. To get the denominator same as 12, we need to multiply 12 with the numerator and with the denominator. So that brings us 12 by 12 minus 1 by 12. So 12 minus 1 by 12, that is 11 by 12. So that is our relative speed. So we would be using this relative speed in a lot of programs, or we can say a lot of questions with clocks. So see you next time with some great questions with this relative speed. But please remember, what is the relative speed of the clock? The relative speed of the clock is 11 by 12. Thank you. Hope you understood. Hope you enjoyed.